Okay, hello, you're welcome to my channel. My name is Solo Anch. Okay, this is McKay. Alright, in this video, we're gonna treat division of examples on division of complex numbers. So in our previous video, we treated a very general case. Okay, where we have an arbitrary complex number. Let's say a plus bi. Alright, this is a complex number where this I here is noted to be the square root of -1. Good. So when we had this divided by c plus di, where we assume that c and d are not the zero real number. Actually, they can be, but the fact that they're in the denominator, okay, this complex number here is in the denominator, we don't want it to be 0, and a complex number is 0 if the two real numbers are zeros. Okay, good. So keeping this in mind, we said, okay, to simplify this, we have to multiply numerator and denominator by the complex conjugate of this denominator. Same thing we do with sorts when trying to divide two sorts together. All right, so doing that, we were able to simplify things, and then we got a very general result which you don't have to memorize. All right, so we are going to apply the same steps we took in the general case in solving these particular examples. But for the second example, we are going to do a very special, or we're going to use a very interesting method. All right, it's going to be different from the first one, and I pretty like the second one, so you stay till then. All right, but the first one, we are going to use the standard method which I just discussed. Of course, we are going to apply it here to see how it looks. So given this expression, 2 plus 9i divided by 5 minus 2i. Actually, note that I can write this question in different ways. Maybe I can call this z1, okay, and then call this z2, and I'll ask you to compute z1 divided by z2. All right, by computing that, I mean this. It's as simple as that. All right, good. So from what we discussed in our previous video, we say that I'm going to multiply this by the conjugate, the complex conjugate of this denominator. So I will say multiply the complex conjugate of this is 5 minus 2i. Okay, so the conjugate will be 5 plus 2i. What we do is that we change the sign of the imaginary part, okay, in a complex number to get its conjugate. Good. So that means we are going to have the conjugate to be 5 plus 2i, since this is minus. So that's what we do, multiply numerator and denominator by this thing. Okay, so you multiply numerator and denominator by the same non-zero number. You have not changed the original fraction. Okay, so by that means that this thing here will become, let's see. So that means that the complex number 2 plus 9i divided by 5 minus 2i is going to be, well, it's the same thing as, let me put down the exact thing, and I'm going to multiply by what we just discussed here. All right, that's 2 minus I. Then we multiply this by, well, you notice that multiply numerator and denominator by the same thing. That will be 5 plus 2i, and then divided by 5 plus 2i. Good. So we've not changed this. They are the same. And the reason is the numerator and denominator here are the same. So multiplying 1 by this fraction, or multiplying this fraction by 1, you haven't changed the fraction. All right, so it stays the same. Good. Okay, so let's see what we have. Well, in the numerator, we notice that this is the same thing as saying 2 plus 9i. Then we multiply it by 5 plus 2i. Then the denominator, this times that, right? 5 minus 2i multiplied by 5 plus 2i. Good. Okay, the idea here is that we don't like the complex number to be in the denominator. So to simplify this, we multiply numerator and denominator by something to eliminate this imaginary notation, this I here in the denominator. All right, and to eliminate that, it is just easy to multiply the complex number by its conjugate. So this is going to be, well, we're going to distribute. Of course, these two will multiply with 5. Okay, the 2 will come here, and then that same 2 will multiply with this one, and then similarly we treat the 9, same thing. All right, so in the numerator we're going to have 2 times 5, which is 10. Maybe let's just do it in our head. All right, 2 times 5 is 10. Then 2 times 2i is 4i. Add it with 9 times 5, 9i times 5. That's going to be 45i. So we add 4i to 45i. That's 49i. All right, good. Okay, just like collecting like terms, adding the two together. Then we multiply 9i with 2i. So 9 times 2 is positive 18. Then I times I is I squared. Okay, we divide this by, well, in the denominator we'll do a similar thing. Use 5 to multiply each of these, just like we used the 2, and then the negative 2i to multiply each of those. That will be 25 here. All right, and then this is 5 times 2i is 10i. You keep the 10i in your mind. Negative 2i times 5 is negative 10i. So 10i minus 10i, that will be 0. So we only have to take positive times negative will be negative. Negative times positive will be negative times 2 is 4. And then I times I is again I squared. Good. But take note that we know that I is the same thing as square root of negative 1. Alright, from the first video in this course. So that means that the I squared will give us a negative 1, since the square will cancel out with the square root. Good. So that means, that means that here will be negative 1, here will be negative 1. So this becomes 10, okay? This is negative 1 times 18. That will be negative 18. So we collect like terms. 10 minus 18. We add 49i to that. All right? And then we divide it by 25 minus, well, keep in mind, I squared is, of course, is negative 1. So this is going to be negative 4 times negative 1. That will be positive 4. 25 plus 4, that's 29. Good. So let's split the fraction into two. To the real part and the imaginary part, because we like a complex number to have this form, the real part and then the imaginary part. Remember the parts of a complex number treated in our first video in this course. Good. So we have 10 minus 18, that will be negative 8. All right, in the numerator. We divide it by 29. Good. That is by splitting the fraction. Then we add this to that. So that will be 49, sorry, divided by 29. Then you put the I right here. Okay, maybe, I know we can simplify this a little more, but it is okay like this. This is negative 8 over 29. Okay, if we try to rewrite this as a mixed fraction, then that will be 1 time, then we add 20 to 29 to get 49, 20 over 29, and then we can put the I right here. So this right here is the result, that is, after taking the ratio, or after dividing this complex number by this one, the result is this. And as you can see, this is the real part. There is no I with this, but this is the imaginary part. All right. So the result after dividing two complex numbers gives us a complex number again. Okay. Yeah, that is the result. But the fact just stated that the result after dividing these two complex numbers has given us a complex number. Don't forget that a real number is also a complex number, right, with imaginary part as 0. Good. We are going to use that fact to as a different method, right, in taking care of this one, given that the ratio of these two complex numbers will be a complex number, so we can equate it to a complex number and see what we can go from there. All right. So I'll clean from here and then the whole part, and then we're going to continue. We're going to solve the second question. But before then, let me just clean this and put down the solution for the first division. So we get this to be negative 8. So I'm going to clean this part and then we're going to do the second one real quick. Okay, so writing out the second question, we have 3 minus 2i divided by 5 plus I. Good. Okay, so using the fact that the ratio of two complex numbers will give us in general a complex number, okay, what I would like to do is to equate this to a complex number. But how will I know that? Because this is what we want to find. So how can you just know the solution? Well, it's not a solution, but we're just going to equate it to some general complex number, and then we're going to try to solve for the values of the real numbers, all right, that will make up that new complex number, which will be the result. So this is what I mean. We equate this to, maybe let me use P plus QI, where P and Q are real numbers, right? And of course, I is square root of negative 1. So this is the idea. Okay, so equate this to a complex number. Now, if we know what P is and what Q is, then we've known what this ratio is. Just like in the first example. In this case, P can be negative 8 over 29, and then Q will be one whole number, 20 over 29. So P and Q are the things we're solving for, right? The constants we're solving for, they are unknown in this case. Good. So working with them as if we know them already, but of course we are trying to solve for them, for each of them. What we'll do from here will be to multiply both sides by 5 plus I, just to, try to start expanding things. So multiplying both sides by 5 plus I, that is, I'm going to multiply the left hand side and the right hand side by 5 plus I. Okay, we are going to have this will cancel out with that. Okay, this will cancel out with that, and then this will be multiplied by this. So we're going to have 3 minus 2I to be, well, I'm just going to put this down as P plus QI. Then we multiply it with 5 plus I. Okay, so this is 3 minus 2I. We equate it to, we are going to expand this bracket here. So you use this P, distribute, and then this part, and then that. So P times 5, of course, that's 5P. We have 5P. Then P times I, of course, that's PI, right? Good. Then QI times 5, 5QI. So we have that to be 5QI. And then QI times I, of course. While computing that, we took note that I squared is going to be -1. So QI times I is going to be QI squared, but positive QI squared. So because of the I squared, we're going to have negative Q, right? So that's going to be negative Q, where the negative is from the I times I, which is -1 times Q, negative Q. Good. The next thing we'll do is this. We remember what I said, although it's not in this video, that two complex numbers are equal if the real part of the first is the same thing as the real part of the second, and if the imaginary part of the first is the same thing as the imaginary part of the second. So that means that implies that 3 on the left hand side, which is the real part of the complex number on the left hand side, will be the same thing as the real part of the complex number on the right hand side. Of course, the real part can be gotten this way. Just take the terms that are independent of the I, right? So like 5P and then negative Q. So we equate this to 5P minus Q. Then the complex part will be, the imaginary part will be, of course, we notice P plus 5Q, right? Good. So the imaginary part, the left hand side, the imaginary part is -2. Remember, it's not the -2I, but just -2. We equate it to PI plus 5QI. So the imaginary part will be P plus 5Q, right? Given that the I is common. Good. So here we have two equations to work with. Equation 1 and equation 2. Isn't that very interesting? Well, yeah, it is. So let's continue over here. No, I like using this. I think it cleans better than the marker, but it's okay. Okay, so let's see what we have. Well, we work with equation 1, so we can solve this simultaneously. This turns out to be a simultaneous linear equation, and I'm going to solve this by let's use substitution method. So let's say from equation 2, let's make P the subject. Okay, we observe that P is going to be, from equation 2, P is going to be, and that will be -2 minus 5Q. Okay, so substitute this P, let's call this equation 3. Substitute the expression for P into P in equation 1. So when we substitute, we'll have 3 to be 5P, but this P is -2 minus 5Q, right? Then we subtract Q from that. Good. So let's simplify this and see what we have. Well, this is 3 equals to -10, right? We have -10. Then -25Q minus Q, that'll be -26Q, right? This time that is -25Q. Good. So you try to make Q the subject of formula from there. We add 10 to both sides and we divide both sides by -26. Okay? So this is going to be 13. When we add 10 to both sides, equals to -26Q. So we divide both sides by -26, -26. Good. So in that case, Q becomes, this and that will cancel each other out. Then we have, sorry, this is supposed to be negative. Okay, so we have this to be 13 divided by -26. That will be -1/2, right? Because of course 13 cancels itself 1 and cancels 26 2 times. So we have negative 1 over 2 as q. Good. So this is the value of q, but we are not yet done. We need to solve for p. So we substitute what q is into equation 3. So we have q to be negative 1/2 in equation 3. When we put in that, we're going to have p to be negative 2 minus 5q, but q on its own is negative 1/2. So in place of q here, we're going to put in negative 1/2. So that'll be negative 1/2, right? Negative 5 times negative 1 over 2 is positive 5 over 2, right? And then we add, subtract 2 from that. So p is going to be, well, negative 2 plus, that will be negative 2 plus 5 over 2, okay? So we want to add these two, let me see. Okay, so you want to add these two numbers together, negative 2 plus 5 over 2. So adding these two numbers together, this will be positive 1 over, let's see, negative 2 plus 2, okay, positive 1/2, right? So that will be positive 1/2. Good. So what happens there is that p is positive 1/2 when you add these two together. P is positive 1/2 and q is negative 1/2. So we've solved for the values of p and q. In other words, we have gotten what this is. This is p, okay, and this is q. P is positive 1/2 and q is negative 1/2. So that means that this right here will become positive 1/2 for p, negative 1/2 for q, and then you put the I right here, right? And this becomes the solution to the second question. I know the steps is pretty long, but it's very interesting, all right? When you think about how you can make use of equality of two complex numbers to get it out, okay? But anyway, it doesn't matter the length. I would like to know which of them is the most interesting for you. Just put it in the comment section below, right? Okay, thanks for watching. In our forthcoming videos, we are going to look at how to take the square root of complex numbers. Yeah, it's going to be very interesting stuff. Thanks for watching. Please share this video with your friends.